Good afternoon and good morning. It's 5 p.m. in Paris. As you can see, it's a little bit dark and it's very early in the Silicon Valley because it's something like 8 a.m., pardon me, in Los Gatos, Luc, right?
That's right. Good afternoon and good morning for me.
Thank you for being with us, because I know that you traveled yesterday. You landed not so long ago, so you're probably still in jet lag. I don't know, but it's a good timing because maybe you're still in French time at the moment.
Thank you for having me.
No problem. Thank you for being with us today. So I'm going to go back in my slides because I see that. Okay, people say that people cannot hear me, but my microphone is open and Luc can hear me as well.
That's right.
So yeah, okay. Okay, so good afternoon, everyone. So as you know, these webinars are recorded, so you will have access to the recorded version at the end. It's interactive as well, so you have a chatter. You can ask as many questions as you want, and we will take them when they come. Because we like to have the question in context. So don't hesitate if you have any question that you would like to ask. We like hard questions, and that's why we are here today. So don't hesitate. So my name is Régis Samla. I'm CTO of Blue Morpho, and today, what is the topic today? Maybe you heard that quote before from Elon Musk, which says that manufacturing at scale is mostly a software problem. And actually, this quote was, so Elon Musk mentioned that a little bit before that, that Luc joined the company, joined Tesla. And I'm pleased to introduce you to Luc Leroy, who is the founder of Full Speed Automation. He worked during the last 2 years before, between 2018 and 2020, at Tesla, and he is a man who demonstrated that this quote was actually true. And the topic for today is to talk more about sustainable manufacturing, and let's talk a little bit about that. So thank you again, Luc, for being with us today. And before we get into it, I want to give a few words about Blue Morpho. Blue Morpho, we are the partner of leading organization in technology scouting and innovation sourcing. So we work in data and deep tech, and we like to say that we deliver innovation for positive impact. Our sponsor today is the project DIH Squared, and we want you to know that the European Commission invests in robotics. And from 2021 to 27, the Horizon Europe Framework Program invested 15 billion euros in AI and robotics. And in DIH Square, we are proud to contribute to this effort. And our mission is to make advanced robotics solutions more affordable. And we want to generate innovations that maximizes productivity and optimize agility for European small business and mid-caps. And with the network that we have built together, because DIH stands for Digital Innovation Hub, the square shows how we can multiply the effect of this network. We addressed about 300,000 manufacturing SMEs and mid-caps across Europe. Here is a quick view of all the partners in the project. And today we are about 100 digital innovation hubs in the network. And there are still some possibilities to join. So if you want to join the network, you will be welcome. So as you know, we like these webinars to be interactive, and I want you to play with me right now. So I'm going to start with the first question, and we're going to talk about Luc and who he is, what he does, and what motivates him. So we want you to answer to this poll. According to you, what keeps him up at night? What keeps Luc awake at night? Is it the tracking of CO2 footprint? Is it adopting holistic approach for pollution management? The problem is that having a car produced in Shanghai and send them in Europe, maybe for consumers, maybe that's a concern. And how it can keep the human in the loop in automation. This is also an important point. Or maybe Luc just sleeps like a baby because he has left Tesla and now he running a business on his own is just like holidays. So we're going to challenge that. So Luc, welcome again. So thank you for being with us today. So people are currently replying. So I checked your LinkedIn profile. So we have met a couple of times before today, but I checked your LinkedIn profile and I saw that you started your career as an entrepreneur. I've seen that you have created 2 or 3 companies before you joined, let's say, a real business. And then later you moved to the US and you joined Adobe, and that's where you spend the most time because you spent 12 years at Adobe. And you joined Tesla in 2018 and you left it in 2020 and you founded this company called Full Speed Automation. So you are French, and so the company is both located in the US and in France. So yeah, can you give us a pitch about what is Full Speed Automation and what you do?
Sure. Well, first of all, thank you again, Regis, for having me, and thank you for everything that you guys at Bloomorph are doing, starting with DIH and bringing innovation for a better tomorrow, basically. That's great. Yeah, so I was brought in the US after co-founding a few companies in France. I had a regular job, actually, in the 90s until 98. It was great. Started my first company with 2 friends in 98. And one after another, we were finally successful in 2004 when our company was acquired by Adobe, which is what brought me to the US. I spent indeed a bit more than 10 years with Adobe. I was ultimately responsible for the applications for Acrobat and Reader, as well as PLM. So that was very interesting, getting involved into manufacturing. And I realized that there was a gap between the world of software, mobile development, desktop, web, and the releases we were giving the manufacturing industry. We could tell that the cycles were a bit longer or extremely longer than in the consumer software world. And I was intrigued. So I started to work with some of our customers, great companies, and realized that everything we learned at university, like a couple of decades ago, which are just in time, zero stock, lean manufacturing, were dreams that were pretty far away from being achieved. So I thought it was important, being a environmentalist and naturalist that I am, to be involved in manufacturing to move the needle, to improve things. That's how ultimately, after a few more startups in the US, I joined Tesla. The mission was pretty clear: accelerate the transition to sustainable transportation and ultimately sustainable energy. My role was originally to help integrating autopilot and firmware in the vehicle, and very quickly I ended up being involved in manufacturing. And long story short, that's what got me involved in working with factory software and automation, and ultimately identify the opportunity for another startup, and that's how Full Speed Automation was born.
Exactly. So let's talk a little bit about Full Speed Automation. What is the product? What is it that you offer? What is your value proposition?
Absolutely. So at Tesla, I ended up being the leader for core automation engineering, which is the automation team responsible for developing all automation practices, software that included IT manufacturing, some of factory software and PLM. And so I was very fortunate. I was at the confluence of anything that was manufactured at Tesla for 2.5 years. We were helping also, other companies such as SpaceX that were in that ecosystem. And there was clearly a gap in the field with a missing abstract platform, like a digitization platform, like we have seen for about 20 years in the enterprise software. It became really clear to me that all our vendors and partners were extremely envious of what we were doing at Tesla. They didn't realize how much work and how many engineers we had working on these issues. And that's a model that most companies, most SMEs cannot afford and therefore cannot be successful at. So full speed automation is the first horizontal no-code factory platform. Basically, we had a bottoms-up approach. We digitized every component on the floor. And then in the software world, in the digital world, you manipulate these primitives, these devices, these components in order to gather intelligence, but also to orchestrate what happens on the floor. If you have a minute, I could give you a very quick demo of what Vitesse does, actually.
Yeah, sure, sure. We never did that before, but that's interesting. You are in your lab, so yeah, please go ahead.
Okay, let's do that. I'm actually on a iPad here, so with a bit of luck, I can move around. Switch to another camera. I am right now in our R&D facility in Los Gatos, Silicon Valley. And you can see we have that small mini production line on which we iterate to develop, different types of integration. So for instance, right here, we are working on a French-Swiss robot integration. And you can see that we are using some cupboard because we tend to crash those while we develop this. So we don't create any damage using cupboard. But once we have a good level of confidence, we move these industrial robots in a cage like that. And I will show you how Vitesse can help you manipulate these devices. Next to it, we have a digital twin of the robot that's integrated into that small window over here with some telemetry. So I will show you that Vitesse can give life to all of these things. Station 2 and 3, so that's where we interface with this industrial robot. And we will work very quickly on building such a process as we have here. Here you can see we instantiated that robot. We are talking to an industrial controller over here. And we have a bunch of sensors and motors, as well as this robot connected to that controller. And with a little bit of orchestration between these components, here we will say when the pallet arrives over here, we want to start program number 3 on this robot, and we'll get the telemetry and handshakes to make it happen. How do we program that? I will show you very quickly. I may be a bit clumsy because I'm holding a big iPad in one hand and manipulate Vitesse over here. So in this example, I just did 5 minutes ago a quick and dirty instantiation of multiple devices that we will be manipulating. We have a stack light over there. We have a e-stop. This conveyor is nothing more than a motor with a gearbox and some brakes. And we have a bunch of sensors that are on the line over here. The way it works is I only have to instantiate these components. So for instance, we saw that we have a emergency stop over here. So what I will do is I will go in the Vitesse library, drag and drop a e-stop into the project. I'm going to drop it here. There we go. Maybe you saw that it worked for a fraction of a second. That was Vitesse checking whatever is available in this project, what we have connected, and ultimately generate some code so that I don't have to. And now that I have instantiated that e-stop here, I know that safety is automatically handled at this station. I have instantiated some motors, some sensors, and using—
A little bit more to the right, yes.
Sorry?
A little bit more to the right, yes.
Oh, okay. So can you see those?
Yes, we can.
Right, so these are digital representations of these primitives that I'm using here. And I don't need to know on which protocol, standard, brand they are using. I can just manipulate them in the UI and say, for instance, when the sensor over here detects a part, when the signal is raised in my interface over there, it will start motor number 1 over here. It's like one very easy way to program. There is a better one. So now if I hit start over there, it will compile, deploy, and I should see this line here take life, basically. So it will generate some code. There we go. We can see that the program is running. We can see the correlation, the relationship between these components. And what we said here is that if this detects a part, that should start this motor. If we detect a part here, we should start that motor, which is over there. So you can see that we are switching from one protocol to another completely transparently. So if I drop my palette over here, we can see that it goes through the process. Ultimately, that secondary program over here is going to tell us to start this robot. And we have the digital twin that's actually on the cloud over here, showing us how the robot is running. One issue here is I never stop this conveyance here. So it's really annoying. The only way I have to stop it is to hit my, my emergency stop button over here. So if I do that, indeed, the HMI tells me that it has been triggered. It puts the brake on over here. That's good. And if I wanted to go beyond, but maybe I won't show you that because it will take another minute.
Yeah,
Right.
but that's a great demo. That's a great demo already. Thank you very much. That was the first time we had a real demo from those gatos. And it worked, and it worked. You took some risks, so thank you for that. That's
My pleasure.
always complicated to make a live demo, so I'm sure people appreciate that. So let's look at the poll, what the people think about. Yeah, I'm going to share the results. And actually, we have 27% of the people who think that what keeps you up at night is that we should adopt a holistic approach for pollution management. Other people think that what is really important is that the human should be kept in the loop, and a little bit less for the car production in Shanghai or the CO2 footprint. And most of the people, a good 20% think that now you sleep like a baby. So yeah, maybe you can elaborate a little bit on these different topics. The importance to keep the human in the loop. What do you think?
I'm really pleased that this is the the first topic of discussion. It reflects my thoughts pretty well. I've never really slept like a baby, but this is relatively accurate. Human in the loop is very important, and maybe if the audience checked on our website and what I have posted previously on LinkedIn, indeed, I'm always trying to educate our stakeholders and customers that automation does not mean necessarily replacing humans with robots. It's about making our life better, basically, as humans. And as humans, we have eyes, fingers, brains that are extremely powerful, and they are tasks that humans will always have more value added than robots. However, repetitive, extremely predictable and boring tasks should definitely be fulfilled by robots, and it takes data to understand where these investments needs to be done, basically. So that's right. And also, we need to not forget that companies are here to serve humans, right, and not the opposite.
Right. So we want to talk today about sustainability in manufacturing, and we're going to start to discuss about the good practices. So again, I want to ask to the audience what they think. What are the good practice? And the first option is that anyway, when you're in production, you need speed. So speed is super important. You're called full speed automation. Your product is called Vitesse, which means speed. So you're kind of obsessed with speed. You have to choose the right robots. You need to have a data strategy. You need to use AI and trust the machine intelligence. And the last point is maybe decentralized production could be a good option. So you know that if you participate to our webinars, you know that we like to have some traps and tricks for you. So yeah, maybe Luc, we can while people are answering to this poll. So according to you, is there such a thing as sustainable production? Is it possible, and what should be the good practice in this area?
Yeah, of course. I mean, we will be doomed otherwise, right? So definitely that's possible. We need to define sustainability, versus durable, ecological. These are some challenges, and unfortunately, it's never totally black or white. You're mentioning data here, and I think everything starts with data. We need to understand where we are, where we stand, and what we need to do. And this requires good data sets in order to make decisions.
Right, right. So, according to you, what are the good practices? If you want to, if you are into a manufacturing environment, you're again at Tesla or wherever, one of your customer, what should be the good practice to adopt for sustainable manufacturing?
So, the trend that we are observing is like efficient throughput should look slow. Actually, it's very interesting. Every time we visit factories that are extremely efficient, everything looks boring and slow. And I think that's a key success. The other aspect is the ability to adapt and iterate rapidly is also very interesting. And we had these conversations with you, Regis, and some of your colleagues in the past, where some small and medium industries that have not adopted, Industry 4.0 practices, I believe they have an unfair advantage today, where decentralized, software practices can be more accessible, more affordable than they were 10 years ago. So without having to do the heavy investments that were done, a decade ago, and that unfortunately can be seen sometimes as a golden jail, there is an opportunity, thanks to the technological progress that we have witnessed for the past 5 years, to make the right decisions, to get the best ROI in terms of environmental, societal, and economical impact. So I don't know if it answers your question.
Yeah,
we can go into some more concrete examples as well.
There was another option. We said maybe choosing the right robots. What do you think about that?
That's right. There is always a dilemma between what the company is trying to achieve right now and the capex that comes with it. And looking forward, we tend to supersize the robots or have more general purpose robots. And we're talking about robots here. They can be 6 or 5 axis robots like the ones we have behind us. If you have a 2 or 3 axis gantry that is custom made, it's a robot already, right? So anything that is powered, motorized, and automated happens to be a robot in the field. And there are some practices where maximum throughput is not always the best efficient. People who have been machining for many decades, they know that overloading the equipment is going to result in extra cost of maintenance, and therefore may not be the best return on investment. It's exactly the same with manufacturing, where you will be willing to look into the lifespan of the robot, but also the power consumption of a robot. And so, for instance, to move things at maximum velocity may not be the most efficient way from both a capex perspective, but also a energy consumption. And one example that I have in mind, at one of my previous jobs, we were moving entire cars with very large yellow robots. And you can imagine the amount of energy that you need to move a 3-ton vehicle like the height of 1 story. And by distributing the load on multiple axes, on multiple joints of the robot with the right velocity, these robot controllers are relatively intelligent, and they can regenerate the energy. So basically, they are using the servo motors in each joint as a damper, as a brake. And instead of turning that into heat, basically, and waste that energy, you can reuse it on a different axis. So, the weight that you are using, raising or damping the car, the load down, you use it to move another axis, and that same energy is going to be translated different axes, right? So we could cut by 30% the amount of energy that was used to move that car, knowing that the intelligence that is in the robot controller is already capable of optimizing. So there is already like a 20 to 30% energy. So in the end, you can cut as much as 40 to 45% energy doing the same motion in the same cycle time, being a bit clever as to how you use that. But again, it starts with the ability to measure the amount of energy that is utilized.
What you're telling me sounds like Aikido to me. You have to calculate your motion, save the energy, use the energy to collect it and distribute it again. That's really, that sounds like Aikido to me. That's really fascinating. Have you some examples of places where you have been, because you traveled all around the world, but are there some role models in this area of sustainable manufacturing?
Absolutely. So one instance immediately jumps to my mind, and it's actually the manufacturer of that robot we are talking about. They invited me and some team members when I was at Tesla in Japan, and we had the opportunity to meet the CEO, a great person, very impressive leader, doctor in robotics who graduated in the 60s. So basically, the man who invented industrial robots, admirable. And this facility is actually running in the dark. As you walk through the lines, you have sensors that are turning the lights on so that humans can see what happens. Robots are actually working in the dark. And what happens there is that robots of a certain type build robots of the same types, and they are eating their own dog food to the extreme, if I may say. Like even the material flow is using the same robot. So it's very impressive to see these bits of robots going from one station to another and being assembled by the robot of the same kind. And everything looks peaceful, quiet, and they build something like 2,000 industrial robots of spectacular quality every week. So that was definitely a model. I don't know, how sustainable it is because I was not there when they built the facility, but it looks very peaceful. It's at the bottom of the Mount Fuji, so you can imagine the picturesque, experience. It's peaceful. You see the snow. You're on the balcony, and you see these buildings that seem to be perfectly integrated into nature. There is no truck, so I believe everything happens underground on some automated conveyors, maybe using AGVs. For me, it was a mind-blowing experience, and it's always been an inspiration since.
Yeah, that's great. Great story. So let's look at the results of the poll. I'm sharing now what the people think of what are the good practices in sustainable production. Production needs speed, yes, indeed, but that was a trap because to produce something sustainable, we just heard that you need to move slow. Choosing the right robots is a good point because you have to choose the one that can save energy. And you see, people really agree with you because 53% of the replies say that people need to have a data strategy. So this seems really data is again at the heart of the problem. And 40% think that they should use AI and trust the machine intelligence. We'll come back to that, and decentralized production. So what do you think about trusting the machine intelligence?
That's very interesting. I mean, I'm glad that it comes second after getting the data, basically. But I have a dilemma with that. And, we've talked about keeping human in the loop. Sometimes there is common sense where human can outsmart AI, or not necessarily AI, but it can be, speaking of these robot controllers that are capable of regenerating the energy. It's great when it's here. My experience is that if you combine the experience of a seasoned robot engineer with a smart robot controller, that's how you get the best return on investment, really. So even I would challenge that a little bit, and my recommendation to every business owner, like any facility, any production facility, will be to try to be smart yourself as much as you can, and add a layer of machine intelligence on top of that. But do not completely trust it. Human in the loop always has value. It's been my experience.
Okay, that's a great message. So I suggest we switch to the next step in this discussion. As you know, when we promote this webinars, we like to collect some questions in advance. And I'm pleased that I received this question from Martin Wimmer from Siemens. And the question is how to measure and / calculate and also share and provide the CO2 footprint in a verifiable way during production steps. So today, from my personal experience, what I hear, when you want to calculate the CO2 footprint of a product, you calculate you measure the CO2 footprint of the factory and you divide by the number of products. And that's how you estimate that. But that's not accurate because maybe sometimes you have small products, sometimes you have bigger products. And how can we do that from the bottom up? You just mentioned that with your tools, you are an advocate of a bottom up approach. So starting from the data collected from the factory. So what is your take on that? What do you think? Is it possible to measure a real footprint during the production steps?
That's right. There are some complexities there. I mean, otherwise it will be done already. But let's focus on CO2. Even though one of your questions was about a more holistic approach when it comes to pollution. We focus on CO2 right now. There are other pollutants. I'm thinking of sulfur dioxide. I care deeply for ocean, and we tend to forget about the sulfur dioxide footprint of shipping goods across the world, particularly on ship across the ocean. We've destroyed a significant amount of coral reefs. And unfortunately, it's not something we can revert like we can for the ozone layer, right? Once a coral reef that takes about 100 to 200,000 years to build up is being killed because of pollutant, it's not something that we will see coming back. So we need to act more globally. And that's sharing the same challenge as a CO2 footprint. One of those is thinking of the supply chain of building anything. Let's take a car, because these are numbers that I know pretty well. I know that the chain, value for a car is typically 8 to 9 providers. So if you take a computer that goes in a car for the ABS, the braking system, it's already one, and that supplier will use a chain value of about 6 to 7 providers. So you would have to track each components coming through hundreds of suppliers against hundreds of countries, maybe, or dozens. And that will be extremely difficult to just have traceability on the goods that are coming on the final assembly to get a good idea of the CO2 footprint, right? So let's focus first on what happens inside the facility. So first, we need to understand the quality of the energy that we're using. So in France, for instance, we're fortunate, thanks to nuclear, the CO2 footprint is very low. There are other issues with, from mining to recycling the waste with nuclear, but let's put that aside and focus on CO2. It's pretty cheap energy, something like 23 to 29 grams of CO2 per kilowatt hour that is built. If you look at Central Europe, where you don't have nuclear energy and there are lots of fossil energies that are used to produce electricity, it's not that good. And if we look at the United States, where I live, unfortunately, it's even worse. We have almost like an order of magnitude between France and the US. So it's important to know where the energy comes from. And there are fluctuations during the day as well, right? So that makes it a bit more complicated, and then there is gaining access to the information. That's why traceability telemetry is one hard requirement for every component that we instantiate in Vitess. We need to know how much energy goes through. We have all the telemetry so that we can characterize that, accumulate that, and estimate how much energy is used during the process, cumulative and real time, so that we can cap and potentially trade across lines and make decisions.
Do you have access to all the data you want? Because this is a topic we have discussed before in previous sessions. Sometimes the data are locked in machines. So do you experience the same thing? Do you face the same problem to collect the data?
Absolutely. One of my providers when I was with Tesla wanted us to pay to have access to the data that was generated by hardware and software that we had paid, and owned for like half a decade. So when you think about that, the automation controls world is about a decade, maybe 2 decades behind when it comes to the perspective on data. I believe that everyone in the cloud, mobile web applications today understands that what's valuable is really what you do with the data. It's not accessing the data. We had to pay 2 decades ago to have access to the data. This is behind. That's why that was a hard requirement for Vitess. Anything that is instantiated in Vitess comes with telemetry, and we broadcast for free in the facility, and our customers, different teams can subscribe to that data and do whatever they want with that data. I think that's really important for the industry to adopt that paradigm so that we can allow everyone to iterate on this data, to understand their process, and that's how we are going to move the needle, really, bringing some intelligence on the floor and in supply chain automation and so on. You're totally right.
Mm-hmm. No, that's really interesting. So part of the so if I summarize, access to the data. So just unlock your data. There's no value in the data itself. Somebody in the previous session that indeed data is considered as a new oil, but it's a crude oil because there's a lot of work to do to really exploit that. Circulation of the data is also missing from what I get. And the challenge is also to share that from your suppliers, and to at the moment there's no solutions for that. There's no reference for that, right?
That's right, and we've been talking about measuring, right? So it's data acquisition. The next step is how do you calculate that, and that can be just a fluctuation of cost and how clean the energy is at a given point in time. Just that equation can be, can require a lot of computation, and unfortunately, most small industries don't have the compute on the floor to achieve that. There are many ways we could imagine compiling, aggregating, compiling the data, sharing that. Do we use blockchain? Do we use centralized authorities with anonymization? There are multiple possibilities here to succeed. It requires a lot of investment, and so I believe, and unfortunately, because progress in the field of environment in the past have always been led by authorities, right? You look at the catalytic converters on cars, they had to be imposed, right? Cap and trade, I think, for the industry is helping, but unfortunately, there are some very successful, wealthy, high value-added industries that can still afford to pollute because they simply, purchase. So that's the downside of cap and trade. If you are extremely profitable, you can trade and you don't really care about the environment. And we know of some companies that do that. And when that happens in Europe, then we promote producing offshore because there are some countries where the requirements on pollution and the environment are not as high as in the West, for instance. And so we sort of shoot our own feet where we may be promoting offshore development that translate into putting these goods on carriers that pollute like even more. And we've been degrading the world almost more since we've instantiated cap and trade, actually. And so there are many challenges here, right? So one way I believe could be done is rely on central agencies. You know, there are some initiatives that are trying to aggregate data to suggest ways of calculating the footprint. And the challenge will be to democratize this access to the data and let it, you know, go up from the floor to the cloud, or maybe it's on edge with some local authentication and some devices that will be trusted by these authorities so that we can track CO2 productions. And I think these are only opportunities. And here, you know, Martin is from Siemens. That's an opportunity for Siemens to democratize access to data, and B, maybe provide some edge solutions and secured ways to connect to the cloud so that this data can be processed and trusted.
Yeah, so personal message to Martin, if he wants to share his thoughts on the topic during the next session, next webinar, we will be very happy to have him so that he can elaborate on what you just said. So thank you very much for answering this question. So we mentioned that we like to work with small businesses here. And so the big question is for small business, you mentioned it a little bit. So where to start? If I'm a small business, I'm maybe lagging behind in terms of automation. So how can I move into automation? How can I catch up?
Yeah, absolutely. Good question. Thank you. So, you know, we refer to Industry 4.0 today. I think, you know, this audience here is pretty well qualified to understand what Industry 4 means and what 3 was and where we were with Industry 2. And lots of SMEs are actually still in what we would call Industry 2.0, right? They have scaled, but there is not even motorization necessarily, no traceability. Yet we have customers that are building very good products, high quality, high value added. And when it comes to measuring their CO2 footprint or super scaling, which will require recruiting a lot of people and then maybe drop on the productivity, profitability, or simply because sometimes it's impossible. We have the case in the west of France. We have a couple customers, great industry, but one CEO told me recently that it will probably take him 5 years to staff enough collaborators to fulfill the requirements for like just 1 year of recruiting in order to scale. So motors and robots need to come on the floor. But where do you start? That's actually the answer. You know, they cannot go to spend hundreds of millions of dollars or euros into automating the floor. So we like to start with data. I mean, that's what we've discussed a few minutes ago. And I think the best way is to instrument the floor. It can be smart cameras. It can be pretty dumb sensors just to inform when material is in and out, and scanners. They can be hand scanners. They can be automated. And we see a lot of that. We don't change the way people build their goods. They've been very successful at that. We deploy some scanners, sensors. We deploy a IoT gateway, so Vitesse can run in non-intrusive industrial IoT mode, where we don't orchestrate, we simply gather intelligence, and that helps leadership. And sometimes we even do some consulting for them, take informed decision as to where some automation investment makes the most sense. And then, you know, we iterate on those, we promote rapid iteration, and we keep investing intelligently where we think it will move the needle more significantly.
Very good, very good. You mentioned the problem of having the production made very, very far from the point of use at the end. and that's a real problem. So we hear a lot about decentralized production. The decentralized production sounds like it's counterintuitive, because for a low-cost production, everything must be centralized. So what do you think about that?
It's a matter of value added as well, right? Sure, if you want to sell one product with no customization to the entire world, intuitively we want to believe that one huge factory in the world is going to be more efficient. It's not necessarily true, because that means that you need to have a global supply chain that is going to be unique. And what became pretty obvious to me about 5 to 10 years ago, that's when I decided to leave Adobe. I was extremely happy at Adobe. We are doing great things, but it became to me, as I was working with our customers in the field of manufacturing, biotechs, and so on, that all the concepts of lean manufacturing, zero stock, just in time, and so on, had been developed very intelligently. If you look at car manufacturing again, one factory was basically a city, and you had rubber and steel that was coming, like raw rubber, raw steel, and you had all the shops to build the entire supply chain was basically within a few hundred acres, right? And at the end, you had cars. So yes, it totally made sense to have zero stock and just in time and be super lean, because everything was local. As we globalized the supply chain, this started to be challenged, and COVID has demonstrated that it was more than challenged, it was extremely stressed. So it can be, and it should be, an advantage to have local production, building, manufacturing local goods that will be optimized for local consumption using local supply chain. We can imagine that like a mouse, I have a mouse right here, right? This thing could be made like entirely of plastic in a region of the world that has unlimited access to oil and gas and so on. Other parts of the world, more recycled material, because there is a lot of that. And maybe somewhere else, half of the parts will be made of cast or machined aluminum, and maybe they will be CNC'd or printed through additive. And that's how you will get the best return on investment locally. I'm a strong believer of that.
Yeah, great. I want to talk about one particular case I want to share with the audience. This is a project which was part of the DIH² project, actually, and there's a bit of decentralized production here. So the company is called Farm Cycle, and they produce these flies. They like to produce larvae of flies, and they use a protein to feed animals, because maybe you know that to feed one fish into a farm, you need about 200 fishes from the sea, which doesn't really make sense. So the pet food, for example, is one particular market where this finds a lot of traction. And in fact, you need a substrate to breed the larvae. And then you need about 8 tons of substrate, you name it, that comes from waste of various waste, from farms, from wineries, from breweries, and you need 8 tons of waste to produce 1 ton of larvae. And actually, if you had a concept with a small factory localized to do just the breeding, then you will just move 8 times less trucks, and then the CO2 footprint would be dramatically reduced. In fact, so what I learned from that is decentralized production doesn't mean that you have to decentralize everything, but maybe decentralize some small parts. And in this project, I'm looking forward to see the real things in production, because they took a container, like a shipping container, and they implemented all the robotics in it just to automatically move the larvae during the breeding. So that's one example that I wanted to share. I've got one question from the audience that we're going to take right now. So what 3 main metrics would you say a small business or startup should use to justify the need to use robotics as part of the development or production team for bringing the startup products to market. So that's really where do you put the trigger? What would be the metric that you could use to say, okay, this company can benefit from robotics?
Interesting. So I think, ergonomics is the very first thing that I will look into. And when we think of ergonomics, of course, it's for the, the health and the quality of life of our collaborators on the floor, right? It has an impact on the quality of what we build. Like moving things around with humans can bump, can scratch the goods that we produce. So we talk about robots. There are also cobots that can collaborate with humans, or simply, by motorizing conveyors, you can unload the burden of humans having to move pretty heavy things around. So I think that the first thing is to drive a study that goes through ergonomics, a very non-emotional way, like putting aside the unions, basically, that will tell you, yeah, we need to have a great ergonomics, and that makes sense, but just be very pragmatic about the actual cost of poor ergonomics and how they can be resolved by robotics. That's the first thing we looked at. And every time we've done that exercise, it justified automation just by its own. The second thing is you need data about the throughput, right? And if you have a plan about scalability, motorization and robotization, so automation ultimately can really help. So that's the second axis on which I will invest. And then the customization of goods, right? Do you want to move towards a pool economy where basically every single thing that can come of a factory, a production facility, can be unique? It could have been configured on the website, and in the end, you have something unique. So we think about cars because they've been doing that. There is such a value added. You go to the website, you change the color of the interior and so on. But when we order this online, these are made in California, not too far from here, and you go on their website and they print that before they bake them. That's great. And that can sound counterintuitive. You will think, oh, pool economy, customization is great when humans actually build the goods, because they can change more than a robot the workflow on every single part that is built. But then the recipe management and the traceability becomes extremely difficult. So you need great software automation in order to enable the pool economy and be able to customize, especially when you have a complex material flow where all of the value chain needs to be customized to converge towards the customized good that is finally produced, right? So these are the three axes on which I will invest the most.
Thank you. So it's time for us to conclude because time is flying. So I'm offering to the audience to, if they want to get in touch either with DIH Square, Blue Morpho, or yourself with Full Speed Automation, to learn a little bit more about the product Vitesse, or if they have some thoughts to share with you. So please feel free to connect and to vote on this last poll, and we're going to share the contact with you. So thank you again, Luc. We have time for one more question in the room. Are there any more questions from the audience? So I don't see any at the moment. So again, this session is recorded. It will be made available from the YouTube channel. It will be promoted on LinkedIn through the DIH Square network and from the Blue Morpho website as well. So you will be able to have access to all this information shortly. So thank you again. I think it's today. You're not working today in the US, right?
That's right. That's right. The office is empty right now. This is Thanksgiving, so yeah, I'm going to run back home, greet some friends, cook a turkey, and enjoy in family. That's right.
Okay, so thank you very much for making
Thank
the
you.
effort. We really appreciate your time. We know you had to go specifically to the office just for us, but
My
really we
pleasure.
had a great time with you, and this was a great session again. So thank you very much, and enjoy your day. Have a great evening for all the folks here in Europe. Good night. Bye-bye.
Bye bye. Thank you.